Chapter 2, Section 6 is called Special Functions because it looks at some functions that exhibit some of the same properties as linear functions, but they're slightly different. They're special for a reason, and you're about to find out why. We're going to talk about one type of function, which is the absolute value function, which looks simply like equation form y is equal to the absolute value of x. This one's special because it's actually what we call a piecewise function. It's a different function. It can be pieced together of two separate functions. When x is greater than 0, it actually looks like the function y equals x, which we know is a linear function. So only on the right side of the y-axis, when x is greater than 0, it will be the function y equals x. Which we know has a y-intercept of 0 and a slope of 1. But when x is less than 0, it's actually the function y equals negative x, which again has a y-intercept of 0, but a slope of negative 1 in this case, resulting in a really sweet function here that looks like the letter V. So when you look at absolute value, it looks like the letter V. However, there are many different variations of this absolute value function, just like there are many different variations of a linear function. Not every linear function is y equals x. Sometimes we have y equals 2x plus 3, or y equals negative 2/3 x minus 17, all of which will change the slope and the y-intercept of the linear function. Same type of thing will happen here with absolute value functions, where you might have, for instance, y equals the absolute value of x plus 2, or y is equal to the absolute value of x minus 2. So today here we're going to look at the difference between these two types of functions, what happens to the graph of that function. And we're also going to look at the difference between those two and what is it going to look like when you look at y equals the absolute value of x plus 3 versus y equals the absolute value of x minus 3. Notice there's a very distinct difference here between these two types of functions, and here I'm adding 2 to the independent variable and then taking the absolute value, whereas here I'm taking the absolute value of the independent variable and then adding 3 to it. So a very fundamental difference here. What's going to happen to the graph of this absolute value function when I add or subtract constants to it? To do that, we're going to use a little help from a program that's called GeoGebra, and you can download GeoGebra from my website. If you go here, you can see that there's a link right here to install and start GeoGebra on your computer. And when you click on it, it takes you to the GeoGebra website. Just click on Web Start right here. That will download GeoGebra for you. And you can actually look at this exact same function. I've created this really nice function flyer here where you can see what happens when you change, when you look at the equation of things like y equals the absolute value of x plus 2. And that too you can find from my website. Get out of GeoGebra there. Right down here on the bottom, you can download that, the absolute value GeoGebra file. Make sure that you download GeoGebra first, and then download this file. So when looking at this function flyer here, this really nice looking v, absolute value, you can see over here on the side, it shows you the function is f of x is equal to 1 times x, but 1 times anything is itself. So we're really looking at just the standard y equals the absolute value of x. And you'll see my sliders over here where I can change some values. And notice what happens here when I change the value of b to a positive 2. The function is now y equals the absolute value of x plus 2. That was that first one that we talked about. And look at what's happened here to the graph of the function. It has shifted to the left 2 units. So what should happen if I subtract 2 from x? If I change that value of b to a negative 2, I should end up with the graph of the function shifting to the right 2 units. Before you look at what happens when I subtract or add a value, the constant c here is going to subtract or add a value outside of the absolute value here. Make a hypothesis of what you think is going to happen to the graph of the absolute value function. And you'll notice here when I change it to a positive 3, the graph of the function actually moves up 3 units. And you can see the equation changed over here at the exact same time. So when I move it down to a negative 3, the graph of the function will move down 3. And I can look at variations of this, such as the absolute value of x plus 2 minus 3 will move that letter v here in the coordinate plane, completely translating the graph of the absolute value function. And this brings us back to one very important question, which is what you think about your linear functions and what happens when you multiply x by a constant value. What happens to the graph of the linear function here compared to y equals x? What would happen if I change, instead of adding or subtracting constant values, what if I looked at the graph of y equals 2 times the absolute value of x, or y equals 3 times the absolute value of x? Or we could keep going and we could look at several different variations, such as y equals 1/2 times the absolute value of x. And that's what you're going to discover here tonight. I want you to make sure you go to the website and download that GeoGebra file and take a look at the function flyer and see what happens when I change that value of a, when I multiply the absolute value, when I multiply that absolute value by a constant value.